Yesterday we looked at graphs to determine what type of function they were, whether they were linear, quadratic, cubic, whatever the case may be. Today we're going to look at tables to determine what type of function we are given. And you should have all of the notes on your handout that you're going to need. Please take down some good examples. This is not out of your book. This is something I'm supplementing, something that's kind of putting everything together that we've been talking about. Linear functions, as it says on your page, this table is an example of a linear function. Okay? In order to determine that this is linear, I want you to look at the y column. In the y column, I want to know, am I increasing by the same thing every time? Well, we call that the first difference. That's what we're looking at. So what I want to do is subtract. I'm going to take 0 minus negative 2, which is positive 2. 2 minus 0, 4 minus 2. 6 minus 4. Okay, we're adding 2 every time to our numbers, correct? Negative 2 plus 2 is 0. 0 plus 2 is 2. 2 plus 2 is 4. 4 plus 2 is 6. Agreed? Okay, we call this column right here, this is called the first difference. That first difference is all the same. So that's what makes this a linear function. It makes it linear because that first difference is the same. Of course, we can always plot these points on a graph to be sure that they make a line, to ensure that it is in fact linear. Look at the next table. This next table is an example of a quadratic function. And the quadratic function, the first difference is the same. It's the second difference is the same. Again, guys, please write these down as we go through them. So look at your your first difference. 3 minus 2 is 1. 6 minus 3 is 11 minus 6. 18 minus 11. Okay. Clearly these numbers are not the same, right? So we know it's not a linear function. What we will look at then is our second difference. Well, keep going. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. This column right here is what we call our second difference. That is the same, correct? If the second difference is the same, we would say that this is a quadratic function. You could probably plot these points on xy axis, but it wouldn't necessarily give you a parabola. It just may give you a small piece of the parabola. You may plot those points and it may look like that's maybe all you get. That doesn't really tell us enough, does it? That's why we have to look at the second difference. Linear equation, they're clearly going to be in a straight line. Quadratic, it may be quadratic, it may be cubic. So I would definitely look at those differences to determine what type it is. This next table is also that of a quadratic function. I want to look at these differences to point out something. Sometimes the vertex is part of the table, and this is what happens. 4 minus 7 is
3.
Negative 3. 2 minus 4? 4 minus 2? 7 minus 4? Okay, clearly it's not linear, correct? The first difference isn't the same. So look at the second difference. Negative 2 minus negative 3. Negative 2 minus negative 3 is positive 1. 2 minus a negative 2? 2 minus negative 2. No, 2 minus a negative 2. It's 4. 3 minus 2. 1. This is a quadratic table, and here's how I know. These two numbers are the same, right? We didn't do anything wrong with our algebra to get the 4. That 4 is the result of these two numbers. Do you see that these are opposite numbers? We have negative 2 and positive 2. That would tell me that this right here is the vertex of the parabola. Do you know what I mean by vertex? Well, it could be. That's just the lowest, or it could be the highest one on your parabola. Okay? If your vertex is part of the table, your numbers here will be opposite. Okay? Positive and a negative. And thus this number right here is not necessarily going to follow the pattern that it should. Okay? So if you have one number that's off, good chance it probably is still quadratic. Just look back and say, okay, did we have opposite numbers here? Well, sure we did. Which means that number, that ordered pair, 0, 2, is probably your vertex. Just be looking for that, because that is a very good possibility that that will happen. This is a cubic function. An example of a cubic. Let's look at this one. In this case, the third difference is going to be the same. So you'll have to go through 3. So let's subtract negative 2 minus negative 2. Excuse me, negative 1 minus a negative 2. 1. 6 minus negative 1. 7. 25 minus 6. 62 minus 25. 27. Is that right? 37, sorry. Okay, our first difference is not the same, clearly. There are different numbers. So look at your second difference. 7 minus 1 is? 6. No, yes. 19 minus 7 is? 12. 37 minus 19? 18. The second difference isn't the same. Look at your third difference. 12 minus 6 is?
6.
18 minus 12 is? 6. Our third difference is the same, so what does that tell me?
It's cubic.
That this is cubic. It's all about those differences. We're subtracting those numbers to find that difference to get to that next term. I think I'm going to have to stop here because Belle's going to read this, and then we'll be able to give you your homework. But we are just looking at these tables and finding first step, see if the first difference is the same, if the second difference is the same, or maybe it's the third difference, and that'll tell me if it's linear, quadratic, or cubic. It is very important that you do your homework tonight because we're going to add to it for tomorrow. So you need to make sure you're staying caught up on that assignment. There's only 10 questions, 10 tables.
On the first number 1 on that.
Yeah.
On that Y, first column.
Is it negative 3? Negative 3.